Problem 4-6 on page M112 and 113 starts to get into some more complicated product costing models. In this problem, the book asks for the costing for two products using a traditional overhead allocation and then again using activity-based costing. The book does not indicate what the products are, but does provide a sufficient amount of data to fulfill the requirements. On your screen is a format that can be used to calculate the product cost using the traditional overhead allocation method. At the top of page M-113, the book indicates the total overhead for the company is $175,000. On the screen, the $175,000 goes into the cell under the label Total Overhead. As indicated in the book, direct labor hours come to 7,000. That number is entered on the screen under the cell containing direct labor hours. With those entered, the formula indicates that traditional overhead allocation would use $25 per direct labor hour for costing products. That's $175,000 divided by 7,000 hours. Again in the book, product C is listed as using 3 direct labor hours. On the screen, 3 goes into the line product C uses. The formula on the next line brings the $25 per hour to the proper cell. The formula in the line below that multiplies the 3 times the 25 and shows per unit overhead cost as $75. Below that is added the $24 of direct material and the $36 of direct labor as shown in the book. The formula at the bottom of the column sums those three numbers and indicates that the cost of manufacturing per unit for product C is $135. Jumping down the screen, the same analysis is done for product D. However, product D uses 4 hours per unit. The per unit overhead calculates to $100. Once again from the book, the direct material is $24 and the direct labor cost is $48. Cost per unit for product D is $172 using the traditional cost method of overhead allocation. Once again on the screen, we jump down a page to calculate the cost pools using ABC costing. The book indicates that there are 2 specific cost pools that don't add up to the total overhead, and that by default leaves one other overhead cost pool. The first cost pool is to include the cost of production setup. On the bottom of page M-112, the book indicates that the total cost for setup is $52,000. That number goes into the cell under the word application. In the sentence above the $52,000, the book indicates that there are 2 production runs for each product requiring similar setup effort. So 2 products times 2 production runs means 4 setups each year. The number 4 goes into the cell to the right of the $52,000 and the words divided by. The formula in the cell below the words divided by calculates each production setup as costing $13,000. That's $52,000 divided by 4. Cost pool 2 is to include production engineering and design changes. At the top of page M-113, the book indicates $26,000 per year for engineering changes. That number goes in the cell to the right of engineering changes. In the chart at the top of page M-113, product C shows 6 engineering changes and product D shows 2. Therefore, the number 8, which of course is 6 plus 2, goes in the cell to the right of divided by. The calculation shows each engineering change as costing $3,250, which is $26,000 divided by 8. Finally, cost pool 3 is all of the other overhead costs that have not been allocated. In real systems at real companies, there will typically be many more cost pools. This example is limited to 3 in order to make the problem manageable in a learning environment. For this final pool, $97,000 is left of the original $175,000. And once the $97,000 is entered to the right of the words Other Overhead, the check total formula that is down 2 cells should equal the $175,000 shown in the book. This check formula sums the three pools above it. Since traditional overhead is allocated using direct labor hours, any other overheads, after splitting out specific cost pools, would also be divided by direct labor hours. So the 7,000 hours goes into the cell to the right of the words divided by, and the calculation results in $13.86 per hour of other overhead. That's $97,000 divided by 7,000. Now that the cost allocation pools have been developed, the actual ABC costing can commence. Before we jump down a page, I would urge you to stop this video and copy down the numbers from the pool so that you'll be able to know what we're referencing back and forth. I'm not going to be jumping up and down on the screen. So now we jump down a page on your screen, and there's a format that can be used to calculate the cost of product C. The first number to enter is the number of production setups. As you may recall, the book indicates 2 production runs per product. Therefore, this product gets allocated 2 production steps. To save time, the $13,000 that was calculated above is brought down using a formula, resulting in $26,000 of production setup overhead for product C. Per the chart at the top of page M113, product C has 6 engineering changes per year. The number 6 goes into the cell to the right of the number of changes. The $3,250 is already in the cell further to the right, and the calculation shows $19,500 of production, engineering, and design overhead for product C. Finally, the chart at the top of page M113 shows 1,000 units produced for product C. Since the chart also shows 3 direct labor hours per unit, $3,000 goes into the cell next to the number of hours. The $13.86 is already pre-entered by formula, and the total other overhead is calculated at $41,580. These 3 calculated pool total numbers are summed in the cell to the right of the words total overhead. The next cell below should contain 1,000, which is the number of units produced for this product, which calculates the per unit overhead of $87.08. To this is added the direct material of $24 and the direct labor cost of $36, as is shown in the book. The final calculation, summing the last 3 numbers, shows a cost per unit of $147.08. Again, jumping down a page on your screen, there is a format that can be used to calculate the cost of product D. The first number to enter is the number of production setups. Once again, the book indicated 2 runs per product. Therefore, this product gets allocated 2 production setups. The $13,000 that was calculated above is brought down again using a formula, resulting in $26,000 of production setup overhead for product D. Per the chart at the top of page M113, product D has 2 engineering changes per year. The number 2 goes in the cell to the right of the words number of changes. The $3,250 is already in the cell further to the right, and the calculation shows $6,500 of production, engineering, and design overhead for product D. Finally, the chart at the top of page M113 shows 1,000 units produced for product D. Since the chart also shows 4 direct labor hours per unit, 4,000 goes into the cell next to the number of hours. The $13.86 is already pre-entered, and the total other overhead is calculated at $55,440. These 3 calculated pool total numbers are summed, and the cell down below them should contain 1,000, which is the number of the units produced for this product. And it calculates the per unit overhead of $87.94. To this is added the direct material of $24 and the direct labor cost of $48, as is shown in the book. The final calculation, adding the last 3 numbers, shows a cost per unit of $159.94. The final requirement in the book asks for your opinion of which method does a better job of costing. I'll leave that to your reading and your analysis thereof. Keep in mind, however, that there are different results. Using the traditional method, the products are costed at $135 and $172 respectively. Using ABC costing, they are $147.08 and $159.94 respectively.